Hello everyone, welcome to my channel. Now my today's video is about the calculation of nodes, that is the number of angular node and number of radial node. If a wave function is given, then they are asked to solve out what is the number of node of the corresponding wave function. If you follow my this video, then you can easily solve out this type of problem. And I have a small suggestion that if you follow my previous video, which link is given in my description box of this video, then you can easily understand how to calculate the number of nodes of number of radial node, number of angular node from a wave function given. So please go through the whole video, and then I hope you can solve out this type of problem, that is a wave function given and you have to calculate the number of nodes. And if you like my videos, if you like my content, then please do subscribe my channel, because your one subscription and one like motivate me a lot, and in this lockdown period, so I can share this type of more types of videos, more videos which is important for the gate, and basically which is from physical chemistry. I think I can help you by this way. So please go through the whole video. Thank you. Now our today's topic is the calculation of the number of radial node and number of angular node. Before starting the explanation of the calculation of number of radial node and number of angular node, at first we have to know what is the meaning of node. Node is basically a plane or a point where we can assume that the probability of finding an electron or the electron density is equal to 0. That means if a wave function is given as psi, then and then the electron density will be equal to electron density will be equal to psi square. If an wave function is given as psi, then the electron density will be equal to psi square. And actually I try to explain what is the basic of the node, what is the basic concept of the node. Now node is a point or plane where the probability of finding an electron or the electron density is equal to 0. Now if psi is a wave function, then electron density will be equal to psi square, and at nodal point or at nodal plane, this psi square will be equal to 0. This is the basic concept of the node. Now there is two type of node. One is radial node, and another is angular node. One is radial node and another one is angular node. Now the question is like that, if a wave function is given and you have to calculate the number of radial node and the number of angular node. So to calculate this, the number of radial node and the number of angular node, there is a thumb rule. And if you follow my previous video, that is the calculation of the principal quantum number, azimuthal quantum number and magnetic quantum number from a wave function given, then you can understand this video. Because the thumb rule is that if a wave function given, that is psi, if psi is for a principal quantum number n, psi is correspond to a principal quantum number n, then the total number of node will be equal to n minus 1, if n is the principal quantum number of a wave function given psi, then the total number of node of that corresponding wave function will be equal to n minus 1. Then the if the azimuthal quantum number is denoted by L for this corresponding wave function, then the number of angular node will be equal to L. So the number of radial node will be equal to the total number of node, that is n minus 1 minus of angular node, that means n minus 1 minus L, that means n minus L minus 1. This is the radial node, this is the number of radial node of a wave function given psi, and the number of angular node is equal to L, and the total number of node is equal to n minus 1. The total number of node is equal to n minus 1. So basically this is very easy calculation, very easy calculation. If you can calculate the number principal quantum number and azimuthal quantum number from a wave function given, then total number of node will be equal to n minus 1, and total number of angular node will be equal to L, and the total number of radial node will be equal to n minus L minus 1. And you can easily evaluate what is the value of n and L from a wave function given if you follow my previous video. I have given the link of the previous video in the description box. You can check this out. Now this is the easiest way to calculate the number of radial node and the number of angular node. There is another way whereby putting psi is equal to 0, you can calculate the number of radial node. Now by giving an example, you can understand this. Now I am taking an example. In my previous video also I take this psi value, that is psi is equal to 1 by root pi z by a to the power 3 by 2 e to the power minus zr by a0. This is the psi, that is psi is equal to 1 by root pi z by a0 to the power 3 by 2 e to the power minus zr by a0. And in my previous video I told how to calculate the number of how to calculate n, L and m from a given wave function, and by follow the rule what I told in previous video, we can calculate the value of n is equal to, here the value of n is equal to 1 and the value of L is equal to 0. Hence the total number of node for this wave function given, will be equal to n minus 1, that means 1 minus 1 is equal to 0. Hence for this wave function the number of angular node will be 0 and the number of radial node will be 0. For this wave function the number of angular node will be 0 and the number of radial node will be equal to 0. And actually this is the wave function of the 1s orbital of hydrogen atom, and for 1s orbital there is no angular node and no radial node present. Now this is a way of calculating the number of radial node and the number of angular node. Here I am taking another example, that is psi is equal to some constant a into z by a0 to the power 3 by 2 z square r square divided by a0 square e to the power minus zr by 3a0 3 cos square theta minus 1. And in my previous video I also told you what is the value of n and l for this corresponding wave function. Here n is equal to 3 and l is equal to 2. Hence the number of angular node for this wave function will be equal to 2, and the total number of node will be is equal to n minus 1, which means 3 minus 1 is equal to 2, and angular node will be equal to 2. So hence here radial node will be equal to 0, as there are total number of angular node is 2 and there is total number of node is 2 and number of angular node is 2, hence here the radial node is 0. And basically this orbital is the 3D orbital of an hydrogen like atom. So this is very easy calculation. Hope you can now able to calculate what is the number of angular node and what is the number of radial node for a wave function given very easily. Now I am telling you the another way of calculation of number of radial node. Like a wave function psi is equal to 1 by root 32 pi z by a0 to the power 3 by 2 minus rho e to the power minus rho by 2, where rho is equal to zr by a0. Now for this type of wave function where r can be now for this type of wave function you can calculate the number of radial node by calculating for which value of r this wave function is equal to 0, for which value of r this wave function is equal to 0, because from the beginning I am telling you at node the electron density will be equal to 0. If psi square is equal to 0, that means psi is equal to 0. Now if the wave function is like this type of wave function, that is here r is a single quantity and there is r square. It is not like that, that is this means 2 minus z r by a0. It means this, that is here r is not a single quantity, there is a positive or negative term, there is a equation involved with the r. You can't put here r square is equal to 0, that means for r is equal to 0 the number of node is this. This is not like that. For this type of wave function you can calculate the number of radial node for which value of r this wave function is equal to 0. For which value of r this wave function is equal to 0, you can calculate that, because here there is an equation of r, and you can put this equation is equal to 0 and then you can calculate what is the value of r. Don't put the r is when r is a single quantity, then don't put this single quantity is equal to 0. You have to put the when r can form a equation, then you can put the this equation is equal to 0 and the corresponding r value, and if from this equation you get there is one type of r value, that is here you can get that zr by a0 is equal to 2, that means r is equal to 2a0 by z. Here you can get there is only one value of r, for that this wave function is equal to 0, that means here the number of radial node will be is equal to 1, that is for one value of r this wave function is equal to 0. If you got if suppose there is a wave function where there is a part 2 minus rho square, there is a part, suppose, then you can put this is equal to 0, then that means you r is equal to plus minus 2a0 by z. Then therefore two r values, this is equation is equal to this wave function is equal to 0, that means here the number of radial node will be is equal to 2, because for 2 r values this wave function is equal to 0. Here for 1 r value this wave function is equal to 0, that means the number of radial node is equal to 1, where r value is equal to 2a0 by z. By this way also you can calculate the number of radial node, and here the number of angular node is equal to 0, because for this wave function L is equal to 0, for this wave function L is equal to 0. I repeatedly tell you that please follow my previous video. If you follow my previous video, then you can easily calculate what is the value of L for this wave function given. Here the L is equal to 0, that means the number of angular node is equal to 0 and there is one radial node, and basically this wave function is a 2 0 0 wave function, that is 2s orbital, and for 2s orbital there is one radial node, there is no angular node. So by this way also you can calculate the number of radial node, putting the equation of r is equal to 0, not r when is a single quantity. I repeatedly tell you, don't put r square or r cube is equal to 0, don't put that. When there is an equation involved with the r, then put this equation is equal to 0, then you can get the number of r values, and what is the number of r values is the number of radial node, because for this corresponding r value the psi is equal to 0, that means the electron density is equal to 0 for this corresponding psi value, and for that, for this wave function the number of radial node will be is equal to the values of r for which the wave function is equal to 0. By this way you can also calculate the number of radial node. I think this video will be helpful for you for calculating the number of radial node and the number of angular node. Thank you for watching, and I think now you can solve out this type of problems, and in GATE 20 there is also a question where they ask you to solve out the number of radial nodes, and I think this was 2 marker question, and I think now you can solve this type of question. And again I am saying, if you like my videos, please do subscribe my channel, and thank you. See you again.